In today's lesson, we are going to be looking at solving multi-step equations, specifically when we have variables on both sides. So a multi-step equation just basically means that we have more than the two steps that we've looked at in the previous two lessons. So just a little bit of a warm-up to get back our understanding of what we're doing when we're solving equations. In general, again, the main things we want to have is opposite operations and balancing. So we use the opposite operations to cancel out to get our variable by itself, and then we balance by doing the same thing to both sides. So if I look at the first example, u divided by 2 equals 8. If I want to get u by itself, I need to get rid of the divide by 2. In order to do that, I'm going to multiply, or do the opposite of dividing by 2, which is multiplying. And then I'm going to balance by doing the same thing to both sides. So I've multiplied the one side by 2 and the other side by 2. When we do that, when we do the opposite operation, it's going to cancel out the values or the numbers on one side, in which case I'm left with u, and on the other side, 8 times 2 is 16. So that means the solution to this equation is u equals 16. 6w minus 4 equals negative 22. When we have a two-step equation like this, we want to get rid of the constant first. So I want to get rid of this minus 4. I'm going to do the opposite operation, which is add 4. Do the same thing to both sides of the equal sign. The one side, it'll cancel out. I'm left with 6w equals negative 18. Now, to get rid of the 6, I'm going to divide by 6, because again, the number or the coefficient and the variable, the operation between them is multiplying. So I'm going to divide, or do the opposite, divide by 6, and I'm going to do the same thing to both sides. One side cancels out. I'm left with w equals negative 3. Which is the solution to this equation. The third example is very similar. Still dealing with the constant first, so I'm going to get rid of the plus 2 by subtracting 2. I need to do the same thing on both sides. One side will cancel out. We have negative 3s left over. Negative 13 minus 2, we get negative 15. And now my last step is to divide by negative 3 on both sides. One side will cancel out, and we have s equals 5, which is our solution to that equation. And again, you're starting to see, hopefully, the same steps over and over again, or the same kind of process. With the two-step equations, we're either adding or subtracting a constant first, and then we're generally dividing by a value after. Finally, we looked at some of these examples, so you could argue that these are multi-step equations, but they're just not going to be as complicated as the ones that we look at today. So in these types of equations, we do want to check to see, do we have any like terms? In this case, we have the 6x and the 2x, and the 3 is on its own. Now, when we're collecting like terms in an equation, we want to make sure that we collect like terms on the same side of the equal sign. So you might say, well, 13 and 19, those are like terms. That is true if they were on the same side of the equal sign. Because they're on separate sides, we cannot collect them. So by collecting like terms, I end up with 8x, or the 6x plus 2x, plus 3 equals 19. Now I'm down to a two-step equation. I'm going to get rid of the plus 3 by subtracting 3. I'm going to balance by doing the same thing to the other side. One side cancels out. I'm left with 8x equals 16. And then now I'm dividing by the coefficient, which is 8. One side will cancel out, and I'm left with x equals 2. So the solution to this equation is x equals 2. Now, there is a Desmos investigation that you can go through to try to look at solving equations with variables on both sides. The link will be in D2L, or you can Google Desmos Megaman multi-step equations, and you should be able to find the activity. Let's look, though, at a mobile to kind of get us introduced to this, because we have looked at mobiles before. So if I want to solve this, let's start out by drawing an equation. So I have an unknown, or two unknowns on one side, so we can say 2x equals, and then I have 5, 5, and 5. Oops. So that means I have 15 plus 1x. Now this looks a little bit confusing because now I have variables on both sides. So I can't just isolate the one variable like we used to do. So it might be actually easier to actually solve it based on the mobile. And if I look at the mobile, because I have x's on both sides, it might help if I cancel them out. So if I get rid of 1x on one side, technically the mobile would be unbalanced, so I would need to get rid of 1 on the other side. And when I do that, I'm left with only one variable, or an x, and then 15 on one side. So by doing that, I end up with x equals, or 1x equals 15. So that tells me that one triangle is equal to 15. This would be my solution because, again, if there's no number in front, we can assume it's 1. So we can say that the solution to this is x equals 15, or the triangle equals 15. Let's look at another example. 3x plus 2 equals 4x, or 2x minus 4. So now, let's try to draw the mobile and see what we would have to do. So if I draw our mobile, I'm going to have three unknowns. Let's say they're squares, x, 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 and then I have plus 2. On the other side, I have two x's, x, x, and then I have a minus 4. So same thing as before. If I want to get x by itself, or if I want to solve for x, and I have x's on both sides, let's try to cancel some of them out. So if I get rid of 1x on this side, I need to do the same to the other. I'll get rid of 2 of them, get rid of another 1 on the other side. Now I'm left with x plus 2 is equal to negative 4. Now this is an equation that we could go through and solve, because we could say, well, I need to get rid of plus 2 here, so I need to get rid of a positive 2 on the other side, or using our mathematical kind of formula, if I minus 2 from one side, I have to minus 2 from the other. Oops. One side will cancel out, and we're left with x equals negative 6. And we can always go back and double check this by plugging in negative 6 into our equation and seeing what we get, or plugging it in for, or subbing it in for x to see what we get. Let's take a look at another example. 4 plus 2m equals 3m plus 19. Again, same idea. I'm going to draw a mobile to help me. So I have my 2m's. Oops. Might be easier if we see them individually. So m, and then we have 14, or positive 4. On the other side, now we have 3 m's. So m, and we have positive 19. Again, we're trying to isolate for x, so we can go through and do the same thing, or m in this case, sorry. So we can go through and do the same thing. Let's get rid of 1m on one side and 1 on the other. 1 on one side, 1 on the other. Now I'm only left with 1m. So this can help me, because now what I can do is I can rewrite this equation as 4 equals m plus 19. Now, even though it's a little bit backwards from how we've seen it normally, it's still a good equation, and now it's a one-step equation. So what we can do now is go through and get rid of the constant. I'm going to get rid of the plus 19 by subtracting 19. Do the same thing to the other side. One side will cancel out, and I'm left with negative 15 equals m. So this would be my solution. Now, what we were doing with the mobiles is we were getting the variables to the same side of the equal sign. So what we're doing is essentially we are canceling out the variables on one side so they only existed on the other. And we can cancel out variables by doing the same thing that we've done before. We can use opposite operations. So this is kind of where collecting like terms comes into play with what we're doing. So if I look at this example here, 9x minus 2 equals 5x minus 14. If I want to get the x's on one side, I need to get rid of them from the other. So in this case, it doesn't really matter which ones we want to do or get rid of. I'm going to say let's get rid of the 5x. If I want to get rid of a positive or plus 5x, I need to minus 5x from the one side. Again, to keep it balanced, I need to subtract 5x from the other side. Now I am putting it underneath the 9x because, again, when we're collecting like terms or when we're subtracting or adding terms, we have to make sure that they're like terms. So I'm subtracting the 5x from the 9x. I'm not subtracting it from the 2. I'm not combining the 9x and the 2 because, again, they're not like terms. Additionally, if you really want to think about it, you could say I have 9x minus 2 minus 5x and then go through and find your like terms. But because I can easily see what the like terms are, I'm just going to directly place the subtraction underneath. Same as before, one side will cancel out. 9x minus 5x is 4x. I have minus 2 still left over. And then on the other side, I have minus 14, because that's all that's left over now. So I've gone from a multi-step equation with variables on the both sides now down to a two-step equation, which we should solve from the last lesson. So we start with our constant, get rid of the minus 2 by adding 2, add 2 to both sides, one side cancels out, 4x equals negative 12. Now I'm down to a one-step equation, dividing by 4, opposite of multiplying, doing the same thing to both sides. One side cancels out, x equals negative 3, which is my solution to the equation. The next example, 2x minus 7 equals 5x minus 8. Again, same idea. I want to get the x's or the variables all to one side. So to do that, I need to cancel them out on one side. Now again, it doesn't really matter how or which side they go to. You might want to choose a way where you end up with a positive coefficient, but again, it really doesn't matter. So in this case, let's keep a positive coefficient. I'm going to get rid of the 2x on the one side by subtracting 2x. I'm also going to do the same thing or keep it balanced by subtracting 2x from the right side. Again, because we're dealing with like terms when we're adding or subtracting, I'm putting the minus 2x directly under the 5x to know that's where I'm subtracting it from. One side will cancel out. I'm left with negative 7 equals 3x minus 8. Now we're down to a two-step equation. Again, get rid of the constant. So get rid of this minus 8 by adding 8. Keep it balanced by doing the same thing to both sides. One side will cancel out. And I'm left with 1 equals 3x. Last step, I'm going to divide by 3. on one side, divide by 3 on the other. Now, you might realize we're going to end up with a fraction, which is okay. I'm going to leave it as 1/3. You could turn it into a decimal, 0.333, and so on. Or you can leave it as a fraction, 1/3, and on the right side you have x. So you have x equals 1/3, or 1/3. The next example, or the third one, again, same idea. So just going through the same steps, get our variables to one side. So in this case, I'm going to show you again how, even though if you get a negative or coefficient in front, it still works. So let's say we're used to getting rid of the variables on the left side. So I'm going to get rid of the plus 3m by subtracting 3m, or doing the opposite operation. I'm going to do the same thing to the other side, minus 3m. One side will cancel out. I'm left with negative 5 equals 2 minus 1m. So now when I've subtracted or gotten rid of the variables on one side, I end up with a negative coefficient, which is fine. All that's going to mean is that in the end, when I divide, I'm going to be dividing by a negative number. Two-step equation, let's get rid of the constant. So to get rid of this positive 2, I need to subtract 2. And you might say, well, how do I know it's positive? Again, look to the sign in front. If we don't see anything, we can assume it's positive. Subtract 2 from the one side, balance it by doing it to the other. One side cancels out. I'm left with negative 7 equals negative 1m. Again, remember, we want to get the value for m, not negative m, not negative 1m. We want it for 1m or just m. So we do need to get rid of this negative 1. By doing so, or to do so, we divide by negative 1, opposite operations, divide by negative 1 on the other side. One side will cancel out. Negative 7 divided by negative 1 is 7, and then I'm left with m on the right side. So the solution is m equals 7. So again, the main thing is getting the variables to one side. Now if we want to check our solutions, again the same thing applies. Let me just rewrite our answers. X equals negative 3, 1/3 equals x, 7 equals m. So again, the same idea applies if we want to check our solutions. We can plug the value in for x and check if our left side equals our right side. So I'm just going to break the two parts apart, left side of my equation, or of the equal sign, right side. And instead of x, I'm going to put negative 3. So 9 times negative 3 minus 2. On the right side, 5 times negative 3 minus 14. We end up with negative 27 minus 2 equals negative 29. On the right side, we have negative 15 minus 14, which equals negative 29. So our left side is the same as our right side. That means that this solution is correct. For our middle equation, even with the fraction, we have our left side and our right side. Now this is where it might be better to leave it as a fraction, because if you use a decimal and you don't use the full repeating decimal of 0.33333 and so on, you may not get an accurate solution, or left side equals right side, right? Because it may be off by a slight decimal place or decimal value. So let's work with our fractions here. We have 2 times 1/3 minus 7. And on the other side, we have 5 times 1/3 minus 8. So this works out to 2/3 minus 7. And this works out to 5/3 minus 8. In this case, 2/3 minus 7 as an equivalent fraction becomes 21 over 3. On the right side, negative 8 becomes, or minus 8 as an equivalent fraction becomes minus 24 over 3. So again, if you're not sure where we got that, 7 over 1, multiply the bottom by 3, multiply the top by 3, we get 21 over 3. Same with the 8. 8 over 1 times 3 to both parts, 24 over 3. So again, we're just creating equivalent fractions. In the end, we end up with negative 19 over 3 and negative 19 over 3. So we do get the exact same left side equals right side, so we have a good solution. Finally, same thing again, left side, right side. Plug or substitute your value in, so negative 5 plus 3 times 7, and 2 plus 2 times 7. We get negative 5 plus 21, and we get 2 plus 14. And we get 16 on one side, 16 on the other. Left side equals right side. So this is a good solution again. So again, if you find an answer, you can always go back and double check to make sure it is the correct answer. And it works for any type of equation, right? Once you have your solution, plug it back in and see if the left side equals the right side. So as a challenge, so I'll leave this one for you. As a challenge, create two different equations that have variables on both sides of the equation and that has a solution of x equals 2. So you want to come up with two different equations similar to what we just did, variables on both sides, and the solution is x equals 2. So there are different ways that you can kind of do this challenge, and again, there's many different answers that you can come up with. An easy way is to kind of work backwards. Or if we kind of work backwards and we know, say for example, let's just start with, we know it has to be x equals 2. So let's work backwards. Let's say we have x plus 4 equals 6. So that means that x equals 2. Now, let's add an x to the other side. So now we have x plus 4 equals 6 plus x. 2 plus 4 is 6. 6 plus 2 is 8. So I could change this to say x plus, well, I could say x plus 6, but that's the exact same thing. Or I could say, well, I know if it's a 2, why don't I say it's 2x? 2 times 2 is 4, plus 2, or plus 4 is 8. So we can kind of work backwards like that. So that might be an easy way for you to kind of work around this challenge. Like work backwards, or pick a number. Say we have 3x plus 14 equals 2x. So if it's 3 times 2, 3 times 2 is 6, plus 14 is 20. 2 times 2 is 4. We would have to plus or add 16 to make it work, to equal 20. So you could kind of work backwards like that, or work forwards by at least coming up with your variables on both sides. We know what the answer has to be, so we can plug that in and see what would we have to add to make it work. So again, those are two possible solutions to this challenge, and again, I challenge you to try to come up with your own. So again, that is the end of the lesson. Again, make sure that you remember that when we have variables on both sides, we want to get the variables all to the same side. We do that by canceling out, the same as we've done before. So we have to make sure that we do understand how to collect like terms and the basics of solving equations, which is opposite operations and balancing. If you're not quite confident with that, again, please make sure you go back and check the previous lessons.